Solving equations. By definition, or a definition, an equation is a statement having two quantities being equal to one another, and they typically do have variables. To give you a quick example of an equation that we're going to solve, or we may solve, is x plus 4 equals 7. As you can tell, it has an equals separating these two components, or these two quantities. What this is saying is this left side is equal to this right side. If you think of a teeter-totter, it's like saying x plus 4 is on one side and 7 is on the other. Since they're equal to one another, the teeter-totter is balanced. And so we're going to use that to demonstrate how to solve equations. Now, when you're asked to solve an equation, what that means is you want to isolate the x on one side, and it has to be a positive x. And we can also check our answer by substituting what we find that variable to be. And we'll do some examples as we go. This first example is an excellent example to start with. It's asking if you were to solve this equation and you came up with an answer of 7 or an answer of 3, would either one of these be true, or would it be a solution? One of them may be, neither one may be. Let's find out. So, our given equation is 2x plus 3 equals 9. Now these are two different questions, two different possible answers. So we're checking to see if either one of these work. What that means is, when you see a 7 and checking to see if it's a solution, for this one we're asking, does x equal 7? What we're going to do is substitute. Everywhere we have an x, we'll replace it with a 7. And we're going to ask ourselves, does this side, left side, equal the right side? So when you do the order of operations, multiply first and then add, 17 equal 9? The answer is no. So therefore 7 is not a solution to 2x plus 3 equals 9. Now part B is asking, what about x equals 3? So let's do that. Same way, substitute the 3 for the x. See if both sides equal. The order of operations states multiply first, then add. Does 9 equal 9? And the answer is yes. So x equals 3 is a solution to this equation. Now that's how we check our answers once we actually start solving these equations. So be prepared for that. Now these next two properties, the addition property of equality, and this is also called the multiplication property of equality. It states that if you have two quantities that are equal to one another, if you add 1 to one side, add something to one side, in this case a c, and that must mean to keep both sides equal, you must add the exact same quantity to the other side, or subtract, or multiply, or divide. What these properties, or how these properties can be summarized, is with this statement: what you do to one side, do to the other. Now when you read this, this states what you do to one side of the equals sign, you do to the other side of the equal sign. And so if you have an x on one side and a y on the other, if I add 2 over here, I gotta add 2 over there. If I subtract 2, I gotta subtract 2, and so on, so on, so on. All we're gonna do is add, subtract, multiply, and divide. Let's keep that in mind. We're getting closer to solving some equations, so be prepared. This is the basic strategy used to solve linear equations. Linear equations just means their variable is a plain old x or plain old y. They don't have exponents higher than a 1. So when you add, or when you solve equations, the strategy is to add, subtract all variable terms to one side of the equation, and then everything else to the other. Combine like terms and then isolate the variable by dividing. That's a lot of mathematical terminology for a fairly simple process. When we're solving these equations, here's basically all we're going to do. We got a couple goes. Goal number 1, we want to isolate x terms. I'm going to use x to represent variables. What that means is you want all your x terms on one side of an equation, and on all the constant terms will be on the other side. That's basically variables on one, numbers on the other. Goal number 2 is to actually isolate x. What that means is you want to end up with a plain old x, equals a plain old number. We need this x to be positive. So this first step is typically done by adding and subtracting, and the second step is typically done by dividing. It just depends on what you're given for each equation. So let's solve a few of these problems. Let's do this first one. X plus 3 equals 9. Now I'm going to use a little teeter-totter to help you understand what's going on. We got a teeter-totter. This problem is saying that on one side we have x plus 3, on the other side we have a 9. What that means is this teeter-totter is balanced because both of these are equal. Now what we want to do, we want to get this x all by itself. We want to end up on the teeter-totter, x on one side, some number on the other. It's the whole goal. Now as you can tell right now, we have a number on the same side of x that we don't want there. We need to get rid of that plus 3. And two things happens when we do this. When we get rid of that plus 3, the x is going to be all by itself, which is what we want. And all the numbers will be on the other side, which is what we want also. And when we have all the numbers on the same side, that means we can combine them. So what we're doing is we're trying to get like terms on one side, so we can combine them. We're trying to make the problem shorter as we do these steps. So if you think about teeter-totter, you want to think about how do we get rid of this plus 3. Now we need to go back up here for a second. When you're doing this process, you should always be thinking opposites, or inverses, or undo, or undoes. If you have addition, the opposite of that is subtraction. If you have subtraction, opposite of that is addition. Opposite of multiplication is division. Opposite of division is multiplication. That's what you want to be thinking. Even though opposite is not the correct word, it's actually inverses or undoing. The opposite's the way most people can relate. So over here, we have a 3 that's being added to the x. We want the x isolated, which means we need to get rid of that 3 that's being added. So what's the opposite of addition? You would say subtraction. And so we're going to take away 3. It's like saying if you take away 3 pounds from one side of a teeter-totter, what's going to happen? Now this left side is going to go up. No longer equal, no longer balanced. To make it balanced again, we're going to come over here and take away 3 pounds from there. And when you do that, you end up with x plus 3 minus 3 on one side and 9 minus 3 on the other. And if you take a closer look, you'll notice like terms. 3 minus 3 gives us a 0, and 9 minus 3 gives us 6. Anytime you have like terms, go ahead and combine them. Now what is x plus 0? X. Over here we have a plain old 6, so instead of having this number, we can actually say we have 6. So what we're saying is that x equals 6. Now I'm going to do several problems, and I'm going to leave out all kinds of steps. I'm just showing you exactly what's going on. So here we go. Let's do y minus 5, showing you all the correct steps, and then I'm going to show you a different example, how many steps you actually need. So when you look at this, you see a y that you want to isolate. We have two numbers that we need on the same side. Also, we need minus 5 away from the y, so the y will be isolated. Because remember, the goal is y equals. So you want to think opposites. What's the opposite of a 5 being subtracted? You would say add 5. And then you think, well, what you do to one side, you do the other. So if I add 5 to one side, I'm going to add 5 to the other. And then we're going to combine like terms. Y is the only term with the y over here, so we'll just write it down. Negative 5 plus 5 is 0. Over here we have two numbers that we can always combine together. Negative 3 plus 5 is 2. What's y plus 0? Y. That's what we wanted. And 2 remains, and we're done. And by the way, we could check our answers as we go. For this first one, since x is 6, you substitute it in for x. Does 6 plus 3 equals 9? The answer is yes. This one, y equals 2. If you substitute the y with the 2, is 2 minus 5 equals negative 3? The answer is yes. Let's do another one before we do the next example, and show you how many steps are really all that's needed. X minus 4 equals 11. Watch this. You gotta know what's going on. We want x equals. We need to eliminate that 4 being subtracted. What's the opposite of subtraction? Addition. Are you going to add 4? Because they're opposites. A negative 4 plus 4 gives you 0. They're like cancel out, and it leaves x. What you do to one side, of the equals, you do the other. What's 11 plus 4? 15, and you're done.